Hello, everybody. Good morning to all of you who are in the Americas, and good evening for the rest. My name is José Carlos Díaz. I am the International Sales Manager of NADS, and first of all, I would like to thank you all for attending our webinar about SIMWARE Framework. This is a special webinar about the use of our SIMWARE evaluation kit. Some of you have downloaded along these past days a copy of our software, but let me only to remind you to send us the form with all the data in order to issue your licenses. The licenses for the evaluation kit are for 60 days, and you will need only to send us the MAC addresses of the 3 computers where you will try our software. Well, with me is José Ramón Martínez. José Ramón is the Presales lead of NADS, and he will support you in along all the process of your evaluation. So please feel free to contact him or contact me in order to ask us for any help or examples, or if you find some problems during the installation, you can send us emails, or even we can chat. Before starting, let me recall also that you have with this tool of the webinar, you have a question tool to ask us at any moment if you find any kind of problems with the sound or whatever. But we would like to receive feedback from you at the end of the webinar in order to explain better the details of the features of the software that we are going to show you just now. So, José Ramón, let's start.
Thank you. Good evening. Good morning. Well, as José Carlos has said, please use the questions of the webinar for asking any question. At the end of the webinar, we will be delighted to answer any question. Well, this webinar is quite lengthy, so we don't have much time, but we will have some time at the end for answering questions. Well, first of all, this is the agenda. We are going to start with a bit of introduction of SIMWARE Framework. Very, very brief, because this is not the proper webinar for that. We have already done a lot of webinars about SIMWARE. We can repeat these webinars for you specifically if you want. These webinars can be found in SlideShare or even YouTube. So, well, after this brief introduction, we will do the real installation in Linux and Windows, and we will see the structure of directories and how to use the tools we are installing. We are not going to enter into full detail of the features of each tool because we don't have enough time. This could be more or less done in 1 or 2 days course that we can arrange for you if you want. Also, with SimDeveloper specifically, we are not entering into full detail because for explaining SimDeveloper, we need to enter in detail with Simulink MATLAB, and this is a webinar its own. So we are not entering into detail. But again, we can do a webinar, and we are planning indeed to do that webinar very soon about OpenDisplay, about SimWare and SimDeveloper. So at the end we will have time for some questions. So briefly, what is SimWare? Well, SimWare can be summarized in three main pillars, in three main ideas. The first one is that SIMWARE is just for creating simulators. You can create a full simulator with SIMWARE starting from scratch, starting from the data model, starting from a data model in a HLA format, in a phone model indeed. Without having to code anything, you will obtain a full simulator, and also we provide tools for managing these simulators. So you can create and manage a small simulator with that. Of course, this is a very basic simulator. SIMWARE doesn't provide, for example, complex visual tools or computer-generated forces. We can create very easily the architecture and the logic for a full simulator, but we are not providing the visual tools. There you can use whatever you want. You can use VR forces, you can use whatever tool you choose. In any case, the backbone in any case in SIMWARE is all the time DDS. Every tool in SIMWARE runs over DDS, and everything communicates through DDS. Nothing is hard-coded, and even the state machine goes through DDS. Well, for doing that, we have some tools. We have, for example, the modeler. The modeler is the key tool that allows you to create the data model. You start from a front model, and then this tool converts this phone model, this HLA model, into a DDS model. So now you have a library for publishing and subscribing in DDS. Again, you don't have to see the code here. You can see it if you want, but the tool is going to compile it for you. Also, we have SimDeveloper. That is a tool that runs over MATLAB Simulink. And here the idea is that with MATLAB Simulink, you can create the simulation models with all the logic you want. And then with SimDeveloper, we are going to wrap these models with all the logic and all the data model you have chosen in the modeler. So these models now can be controlled by a scheduler, and we also, of course, have such a scheduler. Sorry, we of course have this scheduler for doing that. Well, you are not obliged to use MATLAB if you don't want to. Maybe you have your own models. Maybe you have your legacy models. Well, we have experience integrating these kind of models in our architecture. It's not very hard. Then the idea would be wrapping, in this case by hand, these structures with our code. But it's very easy. We have documentation and experience about that also. Third element is PowerLink. PowerLink is for making data bridges. We work over DDS all the time, but we can connect very easily to HLA. We can connect to HLA of Mac, we can connect to HLA of Pitch, we can connect to DIS also. With this tool, we are going to make gateways. We are going to build gateways. In this case, the advantage here is that you only have to care about the data you are going to connect. With this tool, it's very easy to build these gateways, and these gateways then can be used with the same architecture and controlled by the same architecture. So you can connect your already existing federation with our DDS wall. Of course, you don't have to change anything at all in your HLA federation. Well, we provide basic tools for doing things, but if you want to add something more complex or you want to integrate your own library, we provide you with a very simple and very powerful API that is called NcWare SIM. With this library, and also with the output of the modeler, with the library for publishing and subscribing in DDS, you have everything you need for building your own applications over in the same architecture as SIMWARE. With this library and with the modeler and with environmental variables we have, and we are going to provide it for you. You will see it in the installation. You have all the communication layer guarantee. You can use all the communication layer through DDS for publishing and subscribing. You don't have to care about that. You can concentrate in adding your visual tool or wherever. But second pillar in SIMWARE is managing simulations. We can create this simulation from scratch and then we can control them. For doing that, we have a very, very complex scheduler and a very basic simulation console. Why basic simulation console? Because our core architecture is centered on the architecture of simulation, not in providing computer-generated forces or whatever. So this tool is very basic. It's only for starting the simulation, for commanding it, and for creating and controlling the instances of it. Here you can't do waypoints and things like that. What is complex here is the scheduler. The scheduler is part of a set of tools called eHost. eHost is comprised by two tools. One is a scheduler and the other is simulation engines. At the beginning, the scheduler, what it does is this application starts and reads a file. And in this file is the layout of all the simulation. Everything the simulation needs to know: which are the models we are loading, which is the frequency we are using in real time, where are the, well, not where, but which are the simulation engines we are using, because where can be anywhere, because we are dealing with distribution simulation, is in this file. So the scheduler starts and reads this file. And after that, the simulation engines using DDS ask for this information. And the console also asks for this information to the scheduler. So the idea is everything is communicated through DDS and everything is generic. Nothing is hard-coded. At the beginning of the simulation can be any, can compromise any kind of data and any layout. Well, we have also the ACS, that is for controlling the simulation. As I said before, this is very basic. With this tool, you can control the state machine. You can command the state machine. And you can create and control the instances of the objects. You can also load and save the scenarios, but here the scenarios are very basic, are only the number of elements and the initial positions of them. This is not, and we are not trying to do that as a computer-generated forces tool or things like that. Since we work with HLA, you can use, for example, VR forces for doing that, or DDS2, etc. Third element is that SIMWARE is for joint simulations. We can connect with HLA from Mac, from Pitch, or with DIS. We have videos, we have demos, we have even a full laboratory where we are connecting DDS World with VR forces without any change, of course. We are connecting to DDS2, in this case through LBC games. We are now working on connecting it to Stage, for example. And the idea is, okay, you have your Federation Assist and we are going to connect it. The only thing that has to match is the data model we are using. And now let's go to the installation. What we are going to do is showing how to install the product in Windows and Linux. We will show the structure of the directories. We will see the environmental variables, which are important, the license file. We will see briefly the communication layer. We will run all the applications available, but not entering into detail because we don't have enough time. This could be maybe 5 or 6 hours to explain everything. we will see the NcWare SIM, that is the API I mentioned before, and we will run an example that comes with the CD, and we will see how to modify this example, because with this example you have all the code on everything you need to play with everything. You have the examples of code of all the elements, and you can change that and recompile, etc. So let's start on Windows. Well, on Windows, what we have on installation is just that. We have one side, SimDeveloper. SimDeveloper is the only tool that runs only on Windows. I mean, all the rest of the tools of Simware run the same and can be installed the same on Windows and Linux. On Windows can be Windows XP, Windows Vista, Windows 7, etc. And Linux can be Ubuntu 10, Ubuntu 12. We can compile it for Red Hat, no problem, but now it's not delivered. But SimDeveloper is only provided on Windows. Why? Well, because MATLAB exists also on Linux, but we are using MATLAB only on Windows. SimDeveloper needs MATLAB to run, but not for the installation. Well, for installing SimDeveloper, it's just a matter of running the setup. And the idea here is that this installation is just going to copy the path, the structure where you say. The only thing that is going to do is copying files in this localization. That's all. Then, after that, you need to open MATLAB and add this path and all the subpaths of it to MATLAB. And then you will be able to use it on MATLAB. Again, this could be very lengthy, so we are planning to do a specific webinar about this part. Returning to the main installation. Well, first of all, we have CMake here. We use CMake for building the solutions in Linux and Windows the same way. With CMake, the system builds a solution using the compiler that is available on the operating system. For example, on Windows, it can use Eclipse, or it can use Visual Studio, or the compiler you have on your machine. On Linux, the same. Can use Qt Creator, can use Eclipse, can use GCC, etc. You are not obliged to install CMake, but if you want to take advantage of the example we have installed in the CD, then you can install CMake. Of course, you can use another version of CMake or have another thing. Well, also we have the Java Java installation here, just in case you don't have Java. And then we have the jar file that is indeed the SimWare installation. On Windows, it's a matter of clicking 2 times. It's going to open. Now you have to choose between Spanish or English. And then, well, the welcome, a warning, the license agreement, and the directory you choose for the installation. You can install it on any directory, but on Windows 7 specifically, this directory has to be created in advance. Why? Because, well, you know, this kind of things about the having an administrative user and things like that. Well, you have to create it in advance on Windows, and that's all. So we have here the list of things we can choose. Well, we have the utils that are sources for communication layer. We have the example here. The example is a full set of code that compromise everything from the data model to the simulation models. Everything is here. You have NcWare, that is the core libraries. You have eHost, that is scheduler and simulation engines. you have modeler, you have ACS, that is the console, and you have also GPGUI. GPGUI, I didn't mention before, is an auxiliary tool we have for building things for ACS. It's an intermediate tool. Also, we have libraries, auxiliary libraries here, and these libraries are for two things. One is for running in the runtime the tools, and the other is just for building new things. We provide you with all the environmental variables to use the API and to compile the API also. So if you install this and run the environmental variables, you will be able to compile anything made with our API and everything made with, for example, Qt, because here we also install Qt. Oh, sorry, Qt is there. Here we also install Qt. So by using our environmental variables, you don't have to care about where are the things located. Well, we have the boost, the ACE, we have searches for XML, we have CMake here, and in this case, what we are installing here is just the modules you need to find our libraries for CMake. CMake need to know where are the things installed, and uses a non-specific system that is not dependent on the operating system. It's a find file. So here we have the find files for Simware. Also we have the OpenSplice version 5.4.1 that you can install it or not. Well, on Linux, we have the same, more or less. Well, this is the installation on Linux. On Linux, we don't have the CMake outside of the installer because CMake is into the installer on Linux. Here we have the install that is going to call the jar file, so it's the same. You have the Java virtual machine, that is a set of Java libraries you need for the installer. And you have the jar file. In Linux, it's very important, you need to be administrator to install that. So you have to make a sudo or use a administrative user. You make the sudo, and in this case I'm going to call the jar file straightforward, so I have to write sudo java -jar and the name of the jar file. The install has exactly the same, has java -jar and the jar file. And then, well, I need the password of the administrator here. And then I have the same, I have the installer, welcome, installation, warning, accept it. The path, well, here on Linux, this path has to exist because it's in the root of the system. So the root of the system is out of the user domain, so this directory has to exist, or an administrator has to build it in advance, has to create it in advance. So now we have to choose between everything. It's just the same. The only difference here is that there is only one version of sources instead of two, and this is a matter of the operating system. And also that here we have the full CMake here instead of having it outside. So now everything has been installed on Windows, and let's see what has been installed. Okay. Well, this is the structure of the folders we have on Windows. Well, first of all, we have the auxiliary libraries. We have ACE, which ACE is a set of libraries we use for tracing and things like that in the code. Boost, that is the same, it's a set of libraries we use for threading and timers and strings, auxiliary things. Indeed, we have the CMake. We have installed. We have Surface, that is used for XML readings. You have the uninstaller, that is a jar file for uninstalling everything. You have the Qt. Here is the Qt version 4.6.3 in this case. You have the communication layer, that is OpenSplice, is the community version 5.4.1. And also you have the NADS directory, and in the NADS directory is everything. Well, you don't have to care about this structure, because we have this file, this environmental file, and in this file we have the paths for everything. So if you run this file, you will have all the paths for running everything in the runtime, and also from compiling anything with our API and with Qt that is included. So let's see this file. Well, in this file we have all the variables. One very important variable here is this, that is called NxLeak. This variable sets where is the license file. By default is in the NADS directory, but you can change it if you want. Well, the license file is here. By the way, this license file has to be called license.xml. Well, we can open this file. Very important here, the version of the elements, the expiration date, and also the MAC that you have provided to us. Well, very important. This license is tied to the MAC. So the device that provides the MAC has to be working, has to be running. I mean, you can send us any MAC. You can send us a Wi-Fi, you can send us Ethernet, you can send us even a virtual machine MAC if you want. But then this MAC has to be running. I mean, in this case it's an Ethernet, so I need to be connected to a network to run this, because if I'm not connected to a network, this device is not working and this MAC cannot be found. What else? Well, here we have the configuration of the communication layer. We are using for that OpenSplice in the version 5.4.1. Out of the box, you can use it and it's okay. You don't have to change anything. But just in case, I'm going to show you. You have here a lot of things you can change. Well, there is a documentation included in the OpenSplice. There are a lot of things you can change here. But again, if you are in a well-established network, you don't have to change anything. Out of the box, it's going to work perfectly. Which is important here? Well, for example, very important is the domain name. The domain name is a string that is the name of the federation or the domain that is, well, it's the equivalent. In HLA we have federations, in DDS we have domains. It's the domain of information that is shared between all the participants in different nodes. Also very important is this address. This address is the way you send information to the network. Can be broadcast, that is by default, can be multicast, and can be a list of IPs. Depending on the network you have, you can change that and use it in advance, in your advance. Well, we also have here all the tools we have installed. The only thing that is not related with the tools is this directory. In this directory we have the modules that add to SIMMake the capability to know where are the things established, where are our applications established. So SIMMake is able to find them and then use them for compiling everything, of course. Well, let's return to Linux briefly. Well, on Linux, we can see that the installation is just the same. This is the structure. In this case, well, the differences are very small. We don't have two versions of sources, but we only have one here. We have the full SIMMake here instead of having only the local modules. And the only difference is that, well, everything is the same. In this case, the path file doesn't exist, but we have a source file. And the source file is just the same. It's the environmental variables you need for running everything in the runtime, and also for compiling anything made with our libraries. For running this source file, you have to use this command, that is source. You write source, you write the path of it. And now, with this command, source and the name of the and the path where is the source file, you load the source file. It's like a bat file, but the way of running it is like that. Well, after this, I'm going to stay in Windows. Everything I'm going to tell you about the tools, the aspect of the tools, the features of every tool, the behavior of every tool is just the same both in Windows and Linux. You can combine Windows against Linux and communicate Windows against Linux. The tools are the same, the behavior are the same, the interface is the same. Well, since we run the same in Windows and Linux, we use the command line both in Windows and Linux. So here we start the command line. Sorry. Well, first thing very important is each time you are going to use SIMWARE, you have to run the bat file. Why? Because if you run the bat file, you will have all the libraries for the runtime and everything for compiling. Of course, you can put that in the starting of the machine or start it in another way. But it's, well, I could say mandatory. You have to run this bat file. Because by running this bat file, you have everything established. You don't have to care where is Qt, where is boost, where is the communication layer. Second thing, you have to start the communication layer itself. The same. This communication layer can start as a service if you want, but can also be run by hand. You have two main commands here. One of these is for stopping the communication layer. That is like that. It's OSPL -A, and the other is for starting it. This communication layer is going to use the file I showed you before. You have to start the communication layer in every node that runs the simulation. I mean, if you are using it in 3 nodes that are 3 machines in Windows, you have to run it in the 3 Windows machines with the same domain. If you are combining this with Linux, you have to start in Linux with the same domain. So the communication now has started and is going to find through the network who is communicating with it. You don't have to care about this. This is a part of the communication. So now let's see the directories. Here we have ACS. ACS is the first two. ACS is the basic console I mentioned before. The structure here is we have the documentation, we have the installation, and we have the user manual. And in the bin we have all the files for running it. We can go to it, and we can launch it. And now it's going to start. Now it's starting. It's taking some time because of the antivirus of Windows, but well, it's Qt, very light. And now you have a console here. Well, I'm not entering into detail of the features of this console. The only thing I'm going to say is that the only parameter that this application has is the domain. You can start it by hand. And now you can say here the domain, the name of the domain. By default, it's going to use the domain 99, but you can say any domain. If you say a domain that is not running, of course, like in the example, is going to fail, of course. Now it's going to fail because the domain doesn't exist. But it's the parameter you have. Well, it's going to fail, exception, etc. Well, here we have eHost. eHost is the set of tools that is the scheduler and the simulation engine. Here we have an example of a file I mentioned before, which describes all the simulation. Well, in this file, you have the description of all the simulation. You have the frequency of the simulation here, for example, in Hertz. You have all the simulation engines we are dealing with, and we are calling them by name, of course, because we don't care where they are located. We are running a distributed simulation, so we don't care if they are in the same machine or in another node, because this is a matter that DDS and the communication layer is going to solve for you. And also we are saying here which models this simulation engine is going to load. In this case, 4 models, etc. So now we can run the scheduler here, for example. By the way, the documentation of eHost is not located here. It's in the SIMWARE doc folder. So now in the bin directory, we can run an example. We have the bin directory, sorry, and we can run the scheduler. Well, a scheduler has a lot of parameters, but by default, it's going to use the domain 99. Here what we have is that the scheduler is starting and is loading and reading this file, the file 99xml. Well, it's not by chance that the name of the file is the same as the name of the domain. It should be the name should be the same. Well, now this scheduler is ready to deliver this information about the simulation to any element asking for it. Later in the example, we can see something running that does exactly that. Well, here in the SIMWARE docs, we have a file called SIMWARE User Manual, and in this manual we can find all the parameters that the scheduler can have. We can run this scheduler over DDS, but we can run it over HLA the same. If you have a federation of MAC or pitch, you can start this scheduler, and this scheduler is going to be a federate like any other over that. You can choose between the level of trace, the way this trace is displayed or not in the screen, in the syslog or even log in this case of Windows, or in a file if you want. Also in this document we have the parameters for the simulation engines. Just the same. You can run these simulation engines also over DDS or HLA in the same way. You have the trace level. You can have no trace at all if you want. The output can be the screen, can be the log, can be CTDR, etc. So for example, now here we can run the motor. In this case I have to put some arguments because by default it's not going to be against the domain 99. But well, this is going to start and then it's going to declare everything in DDS, and it's going to wait for an scheduler to send information for him. He's waiting for someone, for some scheduler anyway in the network for sending him the information for the simulation itself. Well, we have the next is GPWE. You have here the documentation, installation, and user manual. As I mentioned before, GPWE is an auxiliary tool. GPWE is, well, you create the data with the modeler, and then with GPWE you are going to declare the limits of this data. I mean, In the data you can say, okay, we are dealing with airplanes, and with these airplanes has these parameters, for example altitude, for example autonomy. Here in the GPGUI you are going to say, okay, the altitude in this simulation is going to be between 0 and 100 meters, and by default the value will be that. And this information we need for ACS. So ACS, the console, will ask the scheduler for which are the elements of the simulation, and then we'll ask for this kind of information. We'll say, okay, give me the limits of the real simulation. So this is what GPGUI is used for. We launch GPGUI. Again, it's a Qt. Again, it's the same in Windows and Linux. And well, this is the aspect of it. What else? Well, we have a modeler. In the modeler folder, we have both modeler and PowerLink are in the same folder. We have in the documentation the modeler and the PowerLink, and in the bin we have the modeler. Inside this modeler we have both a modeler and PowerLink. So we can launch it. And now we can see, well, each element, by the way, has its own license. I mean, you can buy, well, license on different things, but each tool here, even the API, has separate licenses. Of course, we sell packets of them. No, we don't sell each one individually. Here we have the modeler. That's, well, here you deal with a phone model is the input, or with PowerLink for making the data bridges. Well, the next thing is NcWare SIM. NcWare SIM is the API for building new elements. Here in Bing, you have all the libraries, all the real libraries. The documentation of it is in Simware doc. Here you have this star file. In this star file, there is the doxygen of this API. Well, I have here this doxygen open. And here in this doxygen, you have the description of everything. All the classes, all the modules, all the namespaces, files, etc. Also, here you have a small example in this document of the use of NcWare SIM. Also, in the SimSays example that is included, you have a full example of the use of NcWare SIM for building, in this case, a small client. Well, and finally, what we have here is in Simware folder, we have the documentation, we have SIM, and we have the SimSays example. SimSays example is a full example of an application. We have here models, we have the MATLAB models, we have the code of these models, we have the data model, we have the gateway to connect to HLA, we have the client, we have everything for running this small simulation, and you have all the code available. The tools like Modeler make the libraries for you, but if you like, you can see the intermediate code. Here, you can see this intermediate code. All the code is here. All the panels, everything is here. Everything you need. Also here is, well, we have the code, and also, well, there is a document, of course, of this in the Simware doc. And also we have everything precompiled, so you can run it and you can see the result. Here we have a scheduler that is going to load a file. Here we have the simulation engine, that is that one, that is going to ask for this information for the scheduler. We have the models that are going to be loaded, and this simulation engine is going to load them. Well, this is going to start, and then here you have ACS and everything you need. Well, it's starting, has loaded all the models you need, and now it's going to, each model is starting itself. As you can see here, well, the trace is optional, of course. Every model is declaring the things that can do. I mean, by using DDS, each model is saying, okay, I'm going to put this kind of information, I'm going to subscribe to this kind of information. Everything here has been done by using SIMWARE without coding. The only thing we have coded here is this client. This client, and the code is there, has been made with NcWare SIM in C++ and code for the Qt part. But the rest of it is just made with SIMWARE SIM without coding anything. You have to see the code you want. Well, here we can start. We can init, we can execute. Okay. Okay. So it's not working here because I'm not connected in the network now. Well, but the idea is with that you can launch a small example, and also, which is very important, you can also connect to HLA. You can run these clients the same, and there is code here for doing that. These examples you can run over a federation in HLA. You can run these clients as federates of HLA, the same way. You have also the code here for the gateway, the full code of the gateway. Now, if you want to change this code, well, it's a matter of just going to the directory where everything is installed. This is SIMWARE examples. And now it's a matter of running CMake. Since you have run the environmental variable, you have everything you need to compile. In Linux, just the same. CMake dot. CMake is going to build a solution for you by using the tool available. In this case, for example, in Windows, I have a Visual Studio, so it's going to use Visual Studio. Here, for example, I have 3 Visual Studios, so it's going to use the default Visual Studio. On Windows, I'm using GCC, so it's going to build a solution for GCC. But the same can be done for Eclipse or whatever. For example, here, I have more than one version of Visual Studio, so I'm going to say to it that I'm going to use Visual Studio 2005. Right now, on Windows, we only can use Visual Studio 2005. Why? Because we only deliver the Boost libraries for 2005. I mean, you can use 2010 or whatever you want, but then you have to download from the internet, and these are free, the Boost libraries for these versions. We provide the Boost libraries for 2005, so right now, the product as is, you have to use Visual Studio 2005. Well, we compile the solution. And this is going to create a solution for everything, for the data model, for all the models, for the panels, for the gateways. Everything here is going to make a solution for everything. So after that, you will be able to start Visual Studio and open the solution, as I will show you in a few moments. Well, this is finishing. It's creating the solution for each element, data model, etc., etc. So I think it has finished. It's some moments to create the structure. And now we can launch Visual Studio and use this solution. I can run Visual Studio from outside the command line, but then I won't be able to use the environmental variables I have declared. Of course, from inside Visual Studio, you can run these environmental variables also the same, no? But as I have this here, I'm going to run Visual Studio from inside. That way, Visual Studio will start with the environmental variables, and I don't need to take care about these variables to compile anything. So Visual Studio has started, and now it's a matter of finding the solution that the CMake has left. Well, here it's in saves, we have this solution, and now we can see that this solution here is loading the solution, and now the solution has everything here. Is here. You have all the source code of all the projects, you have all the models, all the simulation modules, you have everything, even the client. You have here the client also, the source code. You can change it and you can recompile it any moment, no problem. The only limitation here is that you have to compile in release mode. I mean, you only can use here release or min-size release. Why? Because again, because we only provide the user with the boost libraries for release. So if you choose to compile it on the back, you will find the problem with the boost libraries. Again, you can download these libraries for the internet in the debug version if you wish, and then you will be able to compile them on the back. Well, this is all for my part. Now, well, I have said before, I don't have enough time to enter into full detail of the tools. Everything is in the documentation, of course. But again, I can make a specific webinar about all the tools, or a specific course, because it could be maybe 2 days course. And about SIM developer, we are planning to make a specific webinar only about this, because it's very complex and it's not easy to solve it in only 1 hour. So now, if you have any question, put it on the questions. Well, here, well, they're asking me about the DIS integration. Yeah, well, in the version you have there, in the version 4.2.2, you don't have DIS. But in the next version that is already delivered, is the version 4.2.3, we have some PDUs for DIS. We don't have the 67 PDUs, but we have the most common that are for entity fire, detonation, and collision, I think. Any more questions?
Okay, thank you very much, Ramon. Well, this has been a previous webinar on developing with SIMWare. We hope this will be helpful for you who are going to work with our software to conduct your own tests and evaluation. But please feel free to contact José Ramon for further support. In advance, I can tell you that this year the SIMWare webinar series will include new webinars about every component of SIMWare. So what we wish is to offer a wide variety of new webinars along the next months in order to get into detail for all the interest of the SIMWare developers community. Sorry. Well, if you have any question, well, I have a question for you, Ramon. Mm-hmm. It's about well, someone is asking why using SIMWare instead of HLA.
Well, SIMWare is well, actually it's a communication layer, and of course, and a standard of simulation, and of course, SIMWare is an architecture. Why? Well, the advantages of using SIMWare, a part of the architecture, is the reusability of the models we provide, and also the use of DDS. The idea is that by using DDS you have a lot of advantage because, well, this is very long, but the thing is that with DDS you can control very well the communication itself. You don't have to care about the communication. You can guarantee the communication. In the case of HLA, some part of the standard tries to avoid the communication if it's not needed. In the case of DDS, we have the communication all the time. There is a paper we presented on CISO Fall last year about this, and you can find it also in our website, I think. Yeah, it's in our website. And there we talk about the difference and the advantages of using DDS instead of HLA.
Another question about licensing. SIMWARE is licensed in 3 editions. We have an academic edition for universities and public research centers. We have a commercial edition and a research edition for private research institutions. And basically we have 2 types of licenses, development licenses and deployment. About prices, we can start from a few thousand euros to, it depends on the size of your project as well as the duration, because we are offering the possibility to get a subscription, a year subscription, so it's better that all of you who could be interested in getting our prices, please feel free to contact me. So please, José Ramón, could you put our contact data in,
yes, for sure,
in the screen?
Yes. Well, another question very important here, the difference between, what they're asking me about the difference between SIMWARE RTI and SIMWARE Framework. Well, this is a very common question. SIMWARE RTI and SIMWARE Framework are 2 different sets of products. SIMWARE RTI is an HLA, HLA over DDS. It's an HLA implementation, pure HLA over DDS, no more, no less. On the other side, as we have seen here, SIMWARE Framework is a full framework simulation. So both of them use DDS, but the approach is very different, and these are different products. Any question? We're out of time. We're out of time, I guess.
Well, we're sorry for being late. Thank you very much for attending this webinar, and please keep an eye on your email, as you will receive shortly a link to this recorded webinar, as well as more news about SIMWARE. Thank you very much. Bye.